We're honored today to be joined by Zhang Peng, Huawei's Chief Storage Architect, who will share with us Huawei's storage explorations and practices over the years, as well as their thoughts about the future.
Storage is a traditional industry that is developing rapidly. Storage systems were first used in the 1960s and 70s for IBM mainframes, which posed high requirements for data reliability, security, performance, and latency.
The data volume was small then, right?
Right, not much data during that period. So from day one, storage was required to provide high performance and reliability. Since late 1990s, especially in the early 2000s, internet technology started to boom. Data volume started to surge. And internet firms like Google started to innovate the storage architecture, giving rise to a brand new architecture called the scaled-out architecture.
What's special about the scale-out architecture?
First of all, it's highly scalable.
Good capacity, expandability?
Right, easy to expand capacity. And it provides large overall throughput, even though nodes alone aren't so powerful. In addition, it is not so latency sensitive, which makes it suitable for background or batch processing tasks. Actually, at the very beginning, the scale-out architecture was made only for these background tasks. However, as we enter the new, intelligent era...
Yeah, the intelligent era. Businesses are going digital.
Right. Their data grows continuously, so they need a resilient storage architecture that provides high performance and reliability for their core transaction scenarios. Traditionally, transaction and analytics workloads are processed using separate storage systems. So after transaction, data is imported for analytics in order to find patterns or identify risks. Shorter and shorter time window is allowed for analytics. In some cases, real-time analytics is required. For example, when you use your credit card in another country, your bank needs to determine right away whether it's a fraud. Identifying frauds in real time is impossible currently. However, if it were possible, banks could eliminate most risks right at the time of occurrence. To do this, the transaction data needs to be recorded quickly, and risks detected as soon as transactions are completed. Real-time and large-scale data analytics is beyond the capability of any current storage architecture. But we do have some ideas, though. We are trying to combine the two technologies in the next round of technological reform in the future. Our idea can be briefly described as a physically distributed, logically centralized, next-gen data storage architecture.
Do we have a name for it?
No, there is no unified industry name for it.
Across the entire industry?
Right, but we can call it by its nickname.
What's that?
Disaggregated architecture. Hardware-wise, units are disaggregated from one another, so no dedicated hardware is used. Okay, no closed hardware either. That means hardware is open to customization based on a standard protocol. The memory will be shared in such a disaggregated architecture. The OS will virtualize nodes into a unified complete system, which then provides capabilities to upper layer applications. Physical distribution and logical centralization lie in the core of the architecture.
Is it still a concept, or do we have something solid?
All I can say is, from our point of view, these technologies can be commercialized or turned into products in the next 2 to 3 years. High-end storage is mainly used in large-scale core transaction scenarios of banks or securities firms. In our opinion, the disaggregated architecture can shorten storage latency, and enable near-data processing, computing, and analytics. It can enable banks to rapidly control risks in real time. The ultimate goal is to enable banks to analyze a transaction within seconds. Underlying innovative applications, mid-layer software and storage software need to collaborate with the upper-layer database software to achieve this goal.
The disaggregated architecture, according to your description, will change our life and significantly boost production and other workloads. It's very meaningful. Thank you for your insights.
It's been my pleasure. Thank you. See you.